Welcome guys. So we are keep solving the math GRE A767 form. 59. We calculate. He asked us about this strange this strange absolute value sum, and ask about the bound. Basically, I mean, if you take the limit for this function, then you know that this what it calculates called arc length. What is calculate arc length of the curve. Okay. So this is 3, this is 1, this is 3, and this is -2, and this is 5, this is 3. Since we know that the limit is calculated arc length, so anytime the functions increase or decrease, we need to capture this and calculate the absolute value for this. So we need to calculate we need to estimate the arc length of this object and find the upper bound. The least upper bound. This is easy because basically this length is 2, and this length is 5, and this length is 7, right? Because 5 minus -2, and this is 2. So the bound is 2 plus 5 plus 7 plus 2, 16. Okay, so the answer is D. Basically, just and ask you about, can you see this? Can you see this function? This set just calculate when you take a limit, it's just calculate the arc length. So when you know this fact, then it's very easy that you can solve it. Okay, so 60. I think 60 is easy question. So I don't. I think it's very easy that the Faraday is told with 360 times. The probability that it comes on to 70 or more, comes 6 on 70 or more of a toes is. Okay, so basically you need to know. Okay, so the key. What is the key? The key is the central limit theorem. Basically, each time you toss a key, which is an independent variable, so you add all the variable up. So you add all the independent variable up, and the n is very large. And from the central limit theorem, this tells you that the result must be the Gaussian variable. Will approximate as Gaussian variable. This approximation is difficult that usually in undergrad, because you don't have real analysis, so you cannot say it very carefully. Basically, this is something called the converging distribution. Okay, so nobody cares. If you you can go to check this is what it means by this convergence. Okay, so since it's Gaussian variable, all you need to is the mean and the variance. So the mean is so each time you press a 6, you toss a 6, the probability is 1/6. So 1/6 times 360 is 60. So the mean is 60, and the variance is n times p times 1 minus p. You need to remember this formula. Okay, so it's 360 times 1/6, 5/6. So basically this is 500, so it's nearly 7. So 7 minus 7, so this is really this is 67 and the 53, and the Gaussian variable, and this is 70. So we need to estimate the portion from this area. Okay, so totally you just see the graph. Okay, so the first A is not correct because it's definitely smaller than 0.5. Okay, so now the problem is B, C, D, which one is correct? right? Because although you can guess the answer should be B or C, but which B or C, which one is correct? Which one is correct? Okay, so which one is correct? So all you need to know is another fact is that for the Gaussian variable, in the first standard deviation, there are 68% data, and the second derivation there are 95% of data. So that means here to here we have 68%, right? So all this shaded region at most contains 1 minus 0.68 divided by 2. So this region must be smaller than 0.16 because this is 0.16. Right. So the region how we want to find is definitely smaller than 0.16. Okay, so the answer is C, between 0.02 and 0.16. So the answer is C. Okay, that's it.